Afternoon. Thanks, Pamela. That was a great daily space update. It was actually really good. Um, it's going to be quite difficult to follow that actually now, but I will give it my best try. All right, guys. So my name is Dr. Matthew Richardson, and this is another stream of CosmoQuest Astro office hours. So let me go ahead and make sure things. Well, I can see it already right now. Things are working just perfectly. Hey, Larry. So let's go ahead and get into things for today. And really, I'm just going to be working on some of the science that I'm doing for CosmoQuest. Specifically, the work that I'm doing with data that was taken by the Moon Mappers app. For any of you guys that are new, if you get the chance, come and check us out, cosmoquest.org, and become one of our citizen scientists. Help us do science. Hey, Linzo. Yeah, Pamela's show today was actually really good. A lot of great things are happening in science. All right, so I've actually kind of hit kind of like a little problem with the work that I'm doing right now for CosmoQuest, and let me try to quickly explain what's going on here. So in the background, I have two windows up, excluding, of course, the image of me at the lower right-hand portion of the screen. But two windows up, the top window being the window where I do all my edits to the source code that I write for the analysis that I do, and the bottom window showing my terminals. Currently, what I'm trying to do is take the user annotations of the images that we have of, in this case, the moon, where those annotations are basically going to be crater markings indicating the size and location of the craters. And I'm attempting to take all of those marks, which makes one bit catalog, and produce what's known as a reduced catalog. So for every single crater, you can have multiple user markings. And to be able to do good science out of this, you'd want to take all of those markings for a single crater and reduce it to just being one marking. And that's kind of what I'm doing right now, and I'm working on being able to visualize that. That is, take an image, look at all the user markings on the image, and then see what the reduced product is of those markings. However, the algorithm that I've written for this is fairly slow. And I'm trying to see if there's ways I can speed it up. But let me show you guys some stuff and to give you a better idea of what's going on here. So let me quickly pull up an image here that I've done in the past that honestly didn't take any time at all to produce, which is the reason why when I recently tried to use the same algorithm to do the exact same thing but with a larger catalog, it's taken like an insane amount of time. Okay, so let's do this. Let's quickly try to pull it up here. Crater projects. You guys can't see what I'm doing right now, but I'm basically just going through a bunch of folders on my laptop here and looking for a good image to be able to show you guys what I'm doing. Auxiliary code, bin, and results. This should be good enough. All right, I'll take this one. So let's go ahead and open that. Let's go ahead and go to, so I'm going to make another scene. I have two scenes open, but I'm going to need to make a new, actually no, let's just add another window. Let's put this plot. That way I can avoid showing a black screen. So, I just changed the aspect ratio of that image, but it's cool. Let's hope you can see this well enough though. I'm gonna shrink it down some more. All right. There we go. All right. So basically what I've done is I've taken, in this case, I've taken one of our images of the moon, and in the top image with just only red circles, I've essentially extracted from our database all the user markings for this single image, and I've just plotted it. I've overplotted it on this image, for the top image that is, with all the red circles. Now, in the bottom image, it's the exact same image. The only difference is that I've run it through the algorithms I have access to, and what it's done is it's reduced essentially the catalog that's composed of all the red circles in the top image, and reduced it to a smaller catalog, where now, of course, we've removed a lot of the annotations or markings, red circles, that are considered outliers, and also generated. I'm going to try my best to kind of zoom in here. Let's see, make sure we get this right. Let's kind of zoom in on like one of these. I think this is perfect, actually. So essentially, if we're looking at this these set of rings here, the red rings that we're seeing are user markings for this crater. So in this case, it looks like there were probably like at least 3 user markings here, which are displayed here by the red rings. And we've taken these user markings and we've created one single ring which corresponds to this green ring that's kind of within the same position and slash the same diameter as the other rings. It's actually an average of the other rings. And I've done this essentially for every single crater. Now, the problem isn't actually producing these images. At least the problem isn't the problem now. The problem now is that it's taking a long time to produce the images. And I'm trying to figure out the reason why. I created this image like a very, very long time ago. Let me quickly look at the timestamp. Yeah, this image was created back in March of 2017. So I really can't tell you exactly what parameters I used to produce this image. I'm pretty sure I can reproduce it if I gave it a little bit of a try, but I'm not going to do that right now. I'm going to focus more so on the data I'm working with now, which is pretty much the same data, but applied to a whole lot more images. But just to make sure that I'm not missing out on comments here, thanks Guido for confirming that everything's going well with the stream. But yeah, this is one of the things that I do here at CosmoQuest. And really this is all in connection to a more larger picture analysis that I'm doing here, which is the incidence angle analysis. But right now I'm kind of focusing on producing these reduced crater catalogs and making sure that the reduced crater catalogs are doing exactly, or looking the way they should look through these visualizations. So let me go ahead and get rid of this. I no longer need it. And let's now kind of dig into the real problem here, which is probably somewhere within the code. And I mean, the code is working. I mean, because I was able to produce the image we just saw. But for some good reason, when the crater catalog is larger, it just takes a longer time to complete. And so to kind of give you an example of what I mean by a long time, let's do this. So I've kind of set the code up right now to output some stuff to the screen, to the terminal. It actually might be useful for me to add some more code here that's going to indicate exactly how long it's taking. I've kind of just been ballparking it just by looking at the clock on my computer and just seeing exactly how long it's taking, but having a more precise reading I think is better. So I'm going to actually import some other code that I've written. Let's do this. Just trying to remember exactly where did I store this. It's gonna be in, actually let's go with incidence angle analysis. I'm pretty sure it's there. Go into the sort, well, include directory first. And so I've actually kind of written a custom, and I mean it's a really simple code to write. Basically it's a timer. It measures the elapsed time between whenever I put a checkpoint in my code. So let's go ahead and copy and paste this over. Let's go to source. Let's go ahead and get the directory in which this is in. Actually, let's go back to include. So I'm just going to go ahead and do a direct copy and paste of this source of the source code and its corresponding header file over to where I need it to be, so I can be able to use it and find out exactly how long it's taking for my code to run here. So copy the checkpoint header file to that directory. So yeah, guys, I'm an astronomer, and during graduate school and undergrad, I had no formal training, of course, in coding. So I learned everything along the way. And if you guys happen to see me doing something that's not right, just point it out. Like, Matt, you could probably do this better this way. So we're going to go ahead and copy this as well. And this is the corresponding source code here. I need to change this to be source. There we go. And I think that should be it. Of course, I'll have to modify my makefile so that everything compiles properly. This is a part of this one, dbscan results plotter. And so it's gonna need to know about. So what I'm doing now, guys, is I'm modifying my makefile so that I can be able to compile the checkpoint code with this particular program that I've written here. So let's see. I'm gonna make sure I don't have any spelling errors, and to also make sure that it's there. There it is, checkpoint. It's apparent I did something weird to my directory here. And the reason why I'm saying that is because the permissions are really crazy here. What's going on? Even though I'm not really worried, this is my own personal laptop, I'm not really worried about anybody doing anything on my laptop as far as like guest accounts or any other accounts, but then again, I don't like to see permissions looking crazy like it is right now. I think what I want to be able to do, and these are header files, so I don't need to, I think it's 644. So all I'm doing now is just changing the permissions on all the files in the current directory. Alright, that's better. And I'm sure I'm missing a ton of comments here. I don't want to miss comments. Exactly. Thank you, Finring. Exactly. Those should not be executable as they're just header files, right? I think I corrected it though. So why astronomy? So funny thing about it, and I know this is off topic, but I love off topic, questions. Funny thing about it, in undergrad, I was honestly, I knew I loved math, right? Math was something that came easy to me. Loved to do it, and I needed to find something to do with math. Oh, really? That's amazing, Larry. Oh man. Honestly, when I was in high school, well, not in high school, but when I was in elementary school, I knew very little about astronomy, and learned very little about it in high school. Oh, but math is it's. I think math is the most important language to learn. Um, it's very important. It's fundamental actually. I mean, learning math is important. And when I was in undergrad, I just knew I loved math and I needed to be able to do something with it. And of course, there are many options. You can go into business and use math there. I mean, use math to count money, right? All day long. But I didn't like business. And I ended up talking to one of the professors who actually did a little bit of scouting for the school I went to, which was Fisk University in Nashville, Tennessee. And he was the astronomy, not the astronomy, but the physics lab professor. So I went and talked to him, and he was like, "You should give physics a try." And so I did that, right? And my very first, I'm going to try my best to also get work done while I explain why I chose astronomy. And so you could do math, but you hate math. I love math. I mean, it frustrates me at times, but I still love it though. But he suggested that I do physics, and so I went ahead. This is my first semester. I went ahead and gave physics a try. Luckily, I was able to test into the calculus class because, of course, that's a prerequisite for physics. And so, I was doing physics, and the professor that was lecturing for the physics course that I was in, love him to death. But and if he ever sees this, I hope he doesn't get upset. But he had the perfect monotone voice in those lectures, and a lot of times by the end of the class, I found myself like waking up from the best sleep I had ever had. But I mean, nevertheless, I ended up still learning a lot. For some good reason, I don't know if it was like, what is the word I'm like osmosis, like it just like absorbed into me what was being taught. I mean, I was able to learn the physics. He did a really good job with teaching it though. And so I just remember one class he was talking about some sort of astronomy concept, and he put a pretty picture up. And when I tell you, so I was born and raised in Chicago, Illinois, and as I stated earlier, in elementary school, I learned nothing about astronomy. Probably, I think we may have talked about the sun at one point, and I think that was as far as talking about like photosynthesis. But prior to high school, I didn't learn anything about astronomy. And even in high school, I learned very little about astronomy. And to see that picture, it was quite amazing. And I mean, I had a really good time learning what he taught that day. That was one of the classes I actually stayed awake for. And soon after that, he got me in contact. That is the professor of that class, or the physics class. He got me in contact with the professor at Vanderbilt University, and I had my very first astronomy internship at Vanderbilt the summer after my first year of undergrad. And we did a lot of work with photometry. In fact, I believe we were working on, if I'm remembering this correctly, uh, it was a binary system. We were looking at the photometry of a binary system. And I just had so much fun doing that, though. So much fun. And I'm so not getting any work done right now, but I'm still enjoying talking about this, guys. And so, I really am going to try my best to, like, make an effort to actually still get this stuff done as well. But I had so much fun with that internship. And every summer after, all the way up through my master's degree, I did an internship in astronomy. and learned a lot of different astronomy, a lot of different areas of astronomy. And so for my PhD, though, I end up doing high energy astronomy, high energy particle physics, or astroparticle physics, and studying the ultra high energy cosmic rays. But in all of that, I want to bring it back to what I'm doing today, which is kind of like coding. It's actually coding for what would be considered, I guess, planetary science, which is not my field of study, but nevertheless, I'm loving what I'm doing. I took no formal courses in coding, none at all, and I'm disregarding the one course I took to introduction to programming in undergrad. I mean, we really didn't do much of anything in that class, but I didn't know anything about programming when I started graduate school for my master's degree, and I mean, it became really important to know how to code, right, to do the analysis that I was doing. But I've learned a lot over the years, and I mean, there's still a whole lot more to learn in both, coding as well as astronomy. So, but yeah, let me get back to what I'm doing here, guys, which is figuring out why it's taking my program so long to run. So let's see. I've put this over to where it needs to be, and I believe I was in the process of modifying my makefile to compile this code. Checkpoint, blah blah blah. That's good. It should be here. It should also be in the corresponding source directory. It's there, and also this is having the exact same permissions problem. Let's go ahead and change that. I don't know what I was doing in the past to make it do this. So I think, yeah, 644. That'll be everything. And everything is fixed. All right. So I can go back one directory where the makefile is at, and I should be able to compile this. Fingers crossed. And come on. It's taking a little bit longer because I have a lot of stuff. Success. Perfect. All right. And it compiled everything as it should have. All right. So now I can go ahead and start incorporating this checkpoint code into my main function. You know what? Funny thing about it, I'm trying to remember exactly what was the how was the way in which I was using this. I'm going to make things easier on myself. I'm pretty sure. Let's see. Let's do this. I'm just going to go ahead and copy and paste one of the ways in which I was using it in this code over here. I'm pretty sure I can just go and look into the source code and figure out exactly how I was using it. Or better yet, actually no. Let's just do it like this. This makes it faster. Incidence angle analysis. Oh, that's another thing. I have to include it. Right. Duh, Matt. I have to include this. So whenever I do my include statements, I always put it in alphabetical order. So starting off with things that are already built in for this for C and my final link, so checkpoint. So pound include checkpoint.h. All right, that should work just fine there. And I'm pretty sure. So what I'm really doing now is I'm just copying and pasting statements that I've made in another bit of code I wrote. This is the lazy way of doing it. It's the lazy but faster way of doing it. I don't have to sit here and try to figure out exactly how I used it. So let's just go ahead and put a checkpoint. So this should go ahead and initialize my checkpoint variable here. And every time I call the checkpoint, I'll need to make sure that I also supply a statement. So, for example, and I'm not really concerned about all of that. Everything that I'm passing up here in the upper window. All it's doing here is just basically opening and reading in some data that I'm submitting to the algorithm, the dbScan results plotter algorithm. And again, I want to make sure that I'm keeping up with comments here. In the past, I have used IDEs. So when I first started off coding, I started off learning how to code in IDL, which is kind of like coding for astronomers by astronomers, if I'm saying that correctly. But yeah, Emacs is not an IDE. I agree with you. Yeah, Emacs is not an IDE. I don't know. When I first started off, I was using an IDE, but then I like slowly drifted away from using them, and now I just use Emacs to directly modify my source code, and then use everything. I do almost everything now from the terminal. It's actually, I mean, and the terminal is really great, right? You can use it, of course, for being able to compile and run, your algorithms, but you can use it for a lot more stuff, right? For your computer itself. And I think learning how to be able to like use a terminal is very important. It's very useful. You're sorry for my loss. The funny thing about it, one of the postdocs when I was in graduate school for my PhD, I actually learned a great deal from him, and he's the reason why I started learning how to program in C and C++. Oh yeah, my dissertation is online. If you need me to, I can go ahead and post the link. But where was I at? I was talking about right IDL, right, and moving on to C. He basically told me that IDL is good and all, but C is so much faster, and he started teaching me so much stuff about C and C++, and yeah, C++ is definitely it took some time to learn. And it turns out there's actually a library that's offered by CERN. It's called the root library. I think it's the root library. And basically it's a bunch of functions, and I basically end up learning how to use all of those functions. I'm actually using those functions right now to be able to produce the plot the image I showed you earlier. Yeah, I mean, I don't know. I mean, learning how to use the terminal is very useful. But I mean, if you can get on without it, I mean, I guess that's okay, right? I think the whole point of computers is to make life easier. But then again, I do feel that if people were to learn how to use the terminal, it would be a lot better actually, a whole lot better. I couldn't agree with you more, Linzo. I couldn't agree with you more. All right, so let me try to get back to this. Oh man, it's 1 o'clock already. Oh, okay. Well, yeah, guys. Typically, for those of you who are new, um, Typically the stream ends at 1 o'clock. I'm probably going to go just a little bit over, not too much. But I really want to see if I can get to the bottom of why my program is not working. I'm sorry, high altitude. You're right. You're right. No. You guys have not wasted my time. Not at all. I enjoy being here with you guys. And I mean, really, the objective of these streams, at least when I'm doing my streams, is problem solving. Whether it be a problem that you guys have generated and we solve it together, or whether it be me working through the problems that I'm having with actual research. No, I love being here with you guys. All right, so let's get back to it. So I end up transferring that checkpoint code over. And now I want to go ahead and actually use it. All of this stuff that I do here should take no time at all. Oops. Let's just get rid of that stuff. And let's say elapsed time since the last checkpoint. Just to ensure everything's working properly. And I'm going to go ahead and exit after this. So back to my terminal. Let's go ahead and compile again. Everything should compile. Whoa. Everything did not compile. Let's figure out the reason why. So what have I done wrong? See, guys, the first problem of the day. Compilation error. So what did I do wrong? I'm missing something here. Wait, did I save this? Okay, it is saved. So there, I go ahead and I use the checkpoint class and declare a variable, checkpoint variable. I do include the header file here. Okay. The make file, if I'm not mistaken, has access. DB scan results plotter, checkpoint. Let's do this. Let's do a make clean. And let's try recompiling and seeing if that works. Okay, there's a lot more information here now. Crater list generator. Error. Non-constant first cannot be narrowed. That is so weird. I was not getting this before. It's funny because I shouldn't be getting these errors. Well, let's just start at the top, see what's going on here. So, error, non-constant expression cannot be narrowed from type double to float. What? All right. You know what? Because I'm not really concerned with the crater list generator code, what I'm going to do is I'm going to temporarily block out all the other executables I'm trying to make here. So I can leave this stuff up. But what I'm going to do is let's copy and paste this line. So in an attempt to kind of reduce not having to worry about all the other executables I'm making, I'm only going to compile just the code that I need, which is executable number 4, the dbscan results plotter. So objects need to be still compiled, but everything else can go away. And I'm going to comment out, I think it's just a pound sign. I'm going to comment out that all. And I probably should comment out these as well. I wonder if I can do this. I wonder if this editor will allow me to just go ahead. I think it's... Oh, perfect. It does work. All right. So I'm just going to go ahead and use the shortcut command for being able to comment out stuff, which in my case is Control-C, Control-C. So I think that should be good for that. So I'm going to go ahead and do another clean. And I'm going to recompile, and hopefully it can ignore everything else I'm trying to... It's still doing it. What? Right, it's the object. It's trying to compile the object itself. Well, I mean, just the source code, not even like... Even though this shouldn't be a problem. That's so weird because it compiled earlier, and now it's having problems. Let's look at comments really quickly. This is all a part of the science process, guys. You go to make some changes somewhere. Exactly, high altitude Cherenkov. I'm pretty sure that's what I did. I even though I don't think I did that, I should have done that, but apparently I did do that. I messed something up here. And now I have to figure out what, you know what? Actually, the best thing to do is just to go back to what it was initially. Compile it, make sure it compiles perfectly. And then, so I probably should like reset everything to how it was initially. So let's actually just do that. And I'm pretty sure I can do this. Oops. Let's go back up. I end up commenting out everything here. But what I can do here, guys, is I can just go ahead and do an escape X, which will now allow me to insert some commands into the Emacs editor. One of those commands I can use to get rid of comments is basically just to uncomment the region. All right, so that should bring those back. I can get rid of this line, uncomment there. The only thing I've added now is the whole checkpoint stuff. So I do want to add that, but let's do this. Let's go ahead and copy this line, paste it, comment out the line that I've modified, and go back to what it was originally. .o. Okay. So now let me go back to the source code. Here, let's go ahead and comment out that. And did I change anything else? I don't believe so. Okay. Let's see if this helps the problem. Let's do a clean. Let's do a recompile. Wait, which directory am I in? I'm in the right directory, all right. Let's go ahead and run it, we'll recompile it and see what happens. Still the same error. Right, my checkpoint is unknown. It notices that. And let's get rid of this also, this checkpoint as well. Buffer, that goes away. All right, I guess I'm kind of forced to now deal with whatever this is. So clean, recompile. I'm pretty sure it's going to give me the same errors, which will require me to actually go investigate code that I wasn't even working on today. Let's see, can that be narrowed from type double to float? Where is this at? So craterless generator. I wasn't even looking at this particular source code, and now I have to go and see what's going on with it. Clustering code. This is going to be in the auxiliary code that I've written here. Source. And now I need to go ahead and open up, what was that? Craterless generator. So really what this code does is it will generate a mock crater list. So basically a bunch of fake craters that I'm creating based off of, I believe I'm using a Gaussian distribution to define the positions. And yeah, well no, wait, let me get that right actually. Sigma diameter, crater mean. If it has a mean, it has a sigma. More than likely, I'm using for this particular source code here, generates a list of craters, of fake craters, and it's generating the diameters using a Gaussian distribution, where the mean crater diameter is 25 units. I can't remember exactly what I should have put what unit I'm using, but just 25 units, and the standard deviation of that distribution is 0.1, so 10% of the mean diameter. So what line was that? So for me to move forward here, guys, I have to fix this one problem that wasn't even a problem before. GSL, okay, what line? 106. So another useful command that I can use with the Emacs editor is go to line. You can kind of see it. It's kind of down here. It's in the top window at the very bottom, where you see the red cursor blinking there. But go to line, press enter, and I can basically just go ahead and jump directly to the line I want to go to, which is line 106. All right. So that's weird. It's only having a problem with that one. It looks like the problem can be easily fixed just by making the array into a double. It's weird. And given that the array P is defined within this for loop, let's just see if that makes the difference. Pushback vector float. Ooh, okay. Let's see if this helps the situation here. At least with this one error. So I'm going to go ahead and compile it again. Let's first do it clear, so I can have a fresh page here. And let's compile. See what happens. Are you serious? So it's been compiling this entire time. And all I did was just change it to a double, and that fixes the compilation error. Oh, that's some. Okay, that was some magic there. I think a gremlin got somewhere in the code and did some stuff there, but that fixed it. The error is just saying you need to explicitly cast a double to float. But yeah, so yeah, I get that, but right, I totally get that Hellfire. But my major issue is that it's been compiling this entire time and hasn't given me any problems until now. But yeah, you're right. I could basically static cast um, that information within the brackets, but yeah, like you said, going ahead and just basically converting the array P into a double was the easiest solution. Less typing involved. And again, thank you actually for noting that, because like I said earlier, guys, I'm learning as I go. No. Nope. And that was in response to high altitude Chernkov's question there. Okay, so man, guys, the time is now 1:18. I'm gonna go ahead and shut down the stream now. But I will be back next week, Wednesday, 12 o'clock p.m. Well, not me specifically at 12 o'clock p.m. Central. So Pamela's going to lead in with daily news, and I'm going to follow up behind Pamela with CosmoQuest Astro office hours. So yeah, guys, join in next Wednesday, 12 o'clock p.m. Central Time for daily news, and then afterwards, CosmoQuest Astro office hours. Guys, thanks again for joining us. Both Pamela and I had a blast talking with you guys about science. And hopefully we can do so again next week, guys. All right. Bye. I'm staying on for a little bit longer just to make sure that the stream was like not cutting out abruptly or anything like that.